Welcome grade 6. We have started a new topic, unit number 9, elements, compounds and mixtures. Today we will discuss what is an atom and the parts of atom, page 123. An atom is the smallest part of an element that can exist and take part in a chemical reaction. Atoms are extremely small, far too small to see with an ordinary microscope. However, atoms are not all the same size. An atom of a gold is much bigger than an atom of hydrogen. All atoms apart from hydrogen are made from three even smaller particles called protons, neutrons and electrons. Protons have positive charge, neutrons have no charge, they are neutral, electrons have a negative charge. The protons and neutrons are packed together in the center of an atom. This is called a nucleus. The smaller electron whiz around the nucleus in tiny orbits. They move so incredibly quickly that they turn into a blurry cloud. This is called an electron cloud. Each atom always has the same number of protons and electrons, making it electrically neutral. However, the number of neutrons may vary. Hydrogen is the simplest atom. It has only one proton and one electron. Helium has two protons and two electrons and two neutrons. Lithium has three protons, three electrons and four neutrons. So atoms is the smallest part element. It cannot be seen with an ordinary microscope. You will require a special type of microscope, that is electron microscope. So all the atoms are made up of three particles, which is a proton, neutron and electron. Proton and electron have the same number and neutrons vary. Protons and neutrons are in the middle, which is known as nucleus, while the electron rotate in an orbit around the nucleus, that is its particular path. The rotation is very quick that we see a blurry cloud known as electron cloud. Hydrogen is the simplest atom, having only one proton, one electron. Helium has two protons, two electrons, two neutrons, and lithium has three protons, three electrons, and four neutrons.
There are 118 different kinds of atoms, which are each the smallest part of an element. As you can see here, atoms are made of just three types of tiny particles called protons, electrons, and neutrons. And each of these tiny particles does something special. For example, it's the number of protons inside an atom that makes each element different. If we look at the periodic table, the first element, hydrogen, has one proton. The second element, helium, has two protons. And the third element, lithium, has three protons. Now, electrons are much smaller than protons, and they zip around protons at lightning speed, making up something called an electron cloud around the atom. Electrons do this because they have a negative electrical charge. All the elements have the same number of electrons and protons. So why do atoms need neutrons? Well, without neutrons, the electric force will cause the positively charged protons to push each other out of the atom. But there's a stronger force that exists between neutrons and protons, which stops the protons from flying apart. It's called the strong nuclear force, or strong force for short, and it kind of works like glue to hold the nucleus together. If there were no neutrons, everything would simply be hydrogen.
Next topic is molecules. Atoms join together to make molecules, and a molecule is made up of two or more atoms chemically joined together. Molecules of elements are made up of two or more atoms of the same type. O is the symbol for oxygen, and 2 means there are two atoms in each oxygen molecule. When two or more different atoms combine, they form a completely new substance called compound. Two hydrogen atoms combine with one oxygen atom to make a water molecule. The formula is H2O. So, molecule. So if there are two same type of atoms, we have a molecule. That is, oxygen has a symbol O and it is written as O2. Similarly, nitrogen has a symbol N and it is written as N2. That means it is a molecule made up of two O atoms, that oxygen atom, and two N atoms, nitrogen atoms. While the compounds are those substances which are made of two or more different atoms, that is, water having a formula of H2O, that is, two hydrogen atom and one oxygen atom. Similarly, we have carbon dioxide, that is, one carbon and two oxygen atom. Next topic is compound and mixtures. All the substances are made up of atoms and molecules because these are too small to be seen with the naked eye. It is common to represent them by small circles or balls. This is our particle model for the atoms and molecules. Elements are made up of one kind of atoms only. Iron is an element because it contains only iron atom. Sulfur is an element because it contains only sulfur atoms. When two or more elements are mixed but not chemically combined, a mixture is formed. A mixture can usually be separated easily. A mixture of iron and sulfur can be separated by using a magnet to attract the iron particles. When atoms of different elements chemically combine together, they form a compound. When a mixture of iron and sulfur is heated, each iron atoms join up with the sulfur atom to form a molecule of iron sulfide. The elements in the compound cannot be separated easily. All the particles are exactly the same, but each molecule contains one iron atom combined with one sulfur atom. The formula for iron sulfide is FeS. Mixtures are the examples of physical change. In a physical change, no new substances are made, and the change is usually easy to reverse. Compounds are examples of a chemical change. In a chemical change, a completely new substance is made, and the change is usually difficult to reverse. So, all the elements are made up of one kind of atom, and we represent the atom by small circles or the balls. Iron in a separate form is element. Sulfur in a separate form is an element. When they are mixed but not chemically, a mixture is formed which is easy to separate. That is, we use a magnet to separate iron from the sulfur. But if we mix it chemically, that is, by heating sulfur and iron, then they will form a compound, iron sulfide. The change will be very difficult to reverse.
In this video, you'll learn the difference between an element, a mixture, and a compound. Firstly, some definitions. An element is a substance that cannot be broken down into anything simpler. A mixture is a substance consisting of two or more substances mixed together, not in fixed proportions and not chemically bonded. And a compound consists of two or more elements chemically combined. Tests. Iron is a metal element, sulfur is a non-metal element. So some iron filings and sulfur powder are mixed together on a piece of paper, and we now have a mixture of iron and sulfur. As said earlier, the components of a mixture, in this case iron and sulfur, are not in fixed proportions. So let's now perform those same four tests on the mixture of iron and sulfur. We can see that the iron in the mixture still sinks and the sulfur floats. The components of the mixture have separated. As the magnet is moved underneath the paper, you will see that iron is attracted but the sulfur is not. Again, as in the test with water, the iron and sulfur can be separated, illustrating the fact that the components of the mixture can easily be separated by physical means. Let us perform the same four tests on a heated mixture of iron and sulfur. For this, we need to carefully select our amounts of iron and sulfur. If the mixture of iron and sulfur is heated briefly and then removed from the flame, a red glow spreads throughout the mixture which turns black. Heating the mixture causes the iron and sulfur to bond chemically to form the compound iron 2 sulfide. This can be shown by the equation. Now let us look at how the compound iron 2 sulfide behaves in the four tests. It all sinks, there is no separation. As the magnet is moved underneath the paper, you will see that the iron 2 sulfide is not attracted as it is not magnetic, so we cannot separate the heated mixture. However, as often happens in class, if the wrong amount of iron or sulfur is used so that there is excess iron, then the iron 2 sulfide will be attracted to the magnet because of this too much iron.
So the change which is difficult to reverse is called a chemical change, and the change which is easy to reverse is called a physical change. In the physical change we have no new substances, but in the chemical change we have new substances. In our daily life we see the salads. Salads are the examples of mixtures. We can separate them easily, and we see a baking of a cake, we see cooking. So both of these are a chemical change because we cannot reverse it into their original form.
Most changes are divided into two categories: physical changes and chemical changes. A physical change is something that changes the physical properties of an object or substance, like size, shape, or form. Cutting a piece of cloth is an example of a physical change. Even though the cloth changes shape and size when it is cut, it does not create a new substance. It's still cloth. Ice melts and becomes water, and water evaporates to become steam. But no matter its form, the water is still water. One way we can tell this is a physical change is that the change can be undone. Water vapor can condense back into liquid water, and liquid water can be frozen back into ice without changing to a different substance. In fact, many physical changes can be undone. For example, we know that dissolving sugar into water is a physical change. Chemical changes occur when the particles of two or more substances are rearranged to form a new substance. For example, when you burn wood, the wood is transformed into a new substance, ash. Just like in baking, this change cannot be undone. Also, chemical changes take place all around us. Metal rusting, fireworks exploding, chemical changes always form a new substance. They may absorb or release heat. Chemical changes usually cannot be undone. Physical changes do not form a new substance. A physical change may change the shape or size of an object. It may change the state of a substance's matter. Many physical changes can be undone in some way.